Yeah.
Not quite. Record. Okay, so gonna quickly go back into the PCB library since I rushed through some of that at the end of last lesson. And then we will be jumping into general project layout, like, yeah, basically starting a project and all of the general startup for that. And based on time, maybe a bit of actual schematic stuff. I'm becoming less and less prepared with these ones. It's more as I go. So last time we saw that if we have a standard surface mount component and we're making the PCB footprint, we can do tools, compliant footprint wizard, choose whatever our item actually is. And they give you, they'll give you the actual chip package name, which is how you'll see it written in DigiKey on some of the items. It'll say it's an SOT or an SOIC item. But you can also see that they give the packages as its capacitor, inductor diode, resistors. And we just have to go through. Typically, we always want to generate the step model just so it looks nicer. It actually gives it legs, colors. It makes it look better than just the gray block. And then it is just a matter of following the data sheet of your component and filling in the values exactly as it's laid out, making sure that you're following the true dimensions and not just the lettering scheme, because sometimes Altium and DigiKey, or the manufacturing data sheets, they'll have a different labeling, so it may not just be L and W on the data sheet. So just making sure of that so you don't accidentally put in the wrong values. Something like no, there's nothing special about those. But yeah, we ran through that last day on kind of how to do those. Any question in general on those? Like using the footprint wizard as it is?
Did you already do connectors?
No, so that's what I wanted to touch on right now.
Cool.
So yeah, because connectors aren't in, they're not in the footprint wizard, and really all they are is through holes, like say our standard 2-pin connector. Just all it is the through hole, and they'll give you the data sheets for these are typically giving you for everything, not just one part. So something to look at. But because all of these is required to be, a couple holes, we have to do these manually in the PCB library. So what we do is place pad, so PP, place pad. Again, we always want to start our designation at 1. For every new component, every new schematic component, pins should always be starting at 1. Or they should be following the data sheet for specific actual chips. And since this is going to be for a header, it's a through-hole component. We leave the layer to be a multi-layer. And then we want a round hole. Hold on a second. Units millimeters, because I prefer millimeters on most things. And change the snap grid to whatever, typically small to begin with. It's better, or it depends on the component. This header will actually benefit from leaving it in imperial, because we can see the pin-to-pin distance is 2.54 millimeters, or 0.1 inch, or 0.1 mils. So for components like these headers, it's actually better to leave it in imperial because of the spacing. So we'll go with a grid of 100 mil.
What's your snap grid shortcut?
What's the, sorry?
The snap grid shortcut.
Oh, just hitting G will bring up the snap grid that has these predefined steps to them. You can modify just your X, just your Y, or set the grid to whatever custom values you want it to be. That's, and then you can, using the standards is typically all you need. So we're going to want to place pad, start off at 1, and you would just go through, say we were doing our 4-pin header. Now, because I set my grid to the 100 mil, just like the datasheet has defined that our pin spacing is, so it's 2.54 millimeters or 100 mil. These automatically sitting at 0, 0. Next one's set to 2.54, so exactly as it was. Another 2.54 from that. So we don't have to do any shifting by minuscule amounts. We were able to just click, click, click. All 4 go on properly. The other thing you could do if you weren't paying attention and maybe you left it in millimeters, if you weren't paying attention and you left it in millimeters, now you're not quite sure, you can always come in and just set these to the proper values manually. And the problem just comes up when you have to do a bunch of these, adding by 2.54, not messing up that math. So when it is something standard values like this, it's best to just set the grid to the exact pin spacing, so you can just go along the entire way. Now, the second part to this, or there's a couple ways you can go about starting this. You can do it as I did and just slap down the 4 holes at the proper spacing. So you just have the 4 holes set across as they should be, but they're not, they may not be the proper hole yet. And then we can resize these now, or you can start by making sure your hole size is the same, is proper, and then throwing the 4 across. But we can see that their recommended layout, all that, 1.09. So we can jump back into here, and we say our hole size to be 1.1 because we don't need that, because it's better to oversize than undersize. You can always just fill it with more solder. Obviously, you don't want to go too crazy, or else it'll just have a terrible fit, and then you'll have to excessively add solder.
Do they already oversize it in the recommended layout?
I'm pretty sure they do.
Like they say 1.09?
Yeah, so that's their oversizing.
Yeah, what's the diameter of the pin? Would say?
Square pin of 0.64.
Okay.
So, yeah, so they're already square pins of 0.64. I don't want to do the trick to figure out what that would actually fit in a circle. But yes, these are already slightly oversized, so we could hit the 109 without a problem. But for the sake of precision, I generally don't care. 1.1 is close enough. Yes. And then I briefly, so we set our hole size to the proper, or to the recommended, typically 1.1, 1.09. Whatever it be. And then we have to define the pad that goes around it. I briefly mentioned it last time, where you want the pad to be typically at least 0.3 millimeters larger. When you go to some PCB manufacturing websites, they'll actually tell you what their minimum allowable is. And I think for the sites that we've used for our 3D or for our PCB printing, they have a minimum of 0.2. So if we have, we'll go back to 1.1. We have a 1.1 diameter. Their absolute minimum they would allow is a 1.3. Like we said, this is the area that we actually solder to. So having a very fine ring is going to make it a bit harder for soldering compared to if we have a nice fat ring. We're able to more easily apply the heat and apply the solder. So we have our hole size, and it's best to at least go 0.3, more if you can, greater than what your hole size is. So 1.5 to this particular one, so you can see we get a better contact area. Now there are trade-offs based on your design of how thick you actually want to go. If you want to be able to conduct a little bit more, or you just want the maximum possible surface to solder to, maybe you would double your pad to hole. The problem becomes if you have a compact board and you want to run traces between. If you were to be running traces through, so that goes to one, and then you would want to be running a couple traces between, you obviously can't have these pads be too large and then constricting this path, because then you won't be able to get any traces through. But you also can't sacrifice having these rings be incredibly thin just for the sake of being able to run multiple lines through it now. So there is a trade-off if you do have a super compact board and you know you want to be running traces between, that you might choose to go on the slightly smaller side of your whole pad, but the larger is a little bit better. And you will sometimes find a component that has a more rectangular or more oval shape peg. I think my board had one. I can't quite remember. You may have components where it's just not. It's not nice. My.
Do you mind re-saying that? I think it cut out for a bit.
Did I cut it out there?
Yeah.
Well.
Hey, can you hear me?
Can you guys hear me?
I can hear Gabriel well. Jared was starting to fade.
Jared, if you could repeat your saying about the square and oval cutouts, we didn't really hear.
Okay. I don't know why. I'm back now. Yeah, you can hear me?
Yeah.
Okay, I don't know why that dropped. Yeah, so sometimes you'll see components, they'll have more rectangular, more ovular pegs. Often you'll see those in snap lock style components. That. Let's see if I can quickly thing. Regardless, whenever you come across these type of connectors, it's best to Still give them a circular, um, hole, give them a circular pad to go through, just for the ease of manufacturing. It's easier for them to just manufacture a straight hole instead of trying to do a nice cutout. So whenever you come across components like that, it's best just to find the minimal sized hole that would allow for your design, and then use that.
Yeah, they'll charge you more if you try to put a square.
So it's, for the sake of what it is, you can get away with just doing a slightly larger hole for those. So that is the preferred option.
Yeah, even the manufacturer recommends that, right? They say just put these holes.
Yeah.
Even though the pin's a square.
Yeah, you don't have to try to match your pins to their perfect shape. Now, I have selected headers that no longer have pegs in them for the most part. Let's see if I can't pull up something else.
Sure, I think the part number in DigiKey actually only has two pegs, two pins.
Yeah, the one that I'm showing right now is only a 2-pin.
Yeah.
But 2 pins is boring to show on a PCB library. But yes, no, I actually should bring that up. I should make that more clear. So yes, the part that I was searching is just this 2-pin header, and this is the datasheet for it. So the datasheet for these connectors, because they're very common to be multiple sizes, so they give you the dimensions for a 2-pin, a 3, 4, all the way up to what would be a 25-pin connector, just because it is a very standard range. So they give you, all of these dimensions are going to be the same for whatever you see them. So distance here, the offset, all of these spacings, they're going to be the same, except for what you can see here, the dimension A and the dimension B, which is your overall pin length and then your overall socket length. That changes with how many pins. So they tell you. So if we were to properly be doing the 2-pin header, which this part number is, we could see that our maximum distance for distance A, pinned first to last pin, is only going to be 2.54, which makes sense because if we only have 2 pins, you only have the one distance, so your max is going to be that same 2.54. The B distance doesn't matter as much to us for the sake of making this library. But then we can also see, like, the recommended, they just tell us what a 4 is, but we can see that it is just repeating of 100 mils for the spin, for the pad, the hole spacing, and the recommended hole. So if we were to follow this, it's only going to be that. If it was let's go back to this. If it was a 5 or 6-pin, we know that the pattern is just going to continue on with this perfect 100 mil spacing between each one, and their hole size would be the same, 1.1, and would carry on. So that is a big one for connectors, especially because they make very generic and just straight through components, that it's the same dimensions for everything. They just keep adding one more pin. So make sure of that whenever you're making a component, that you may have to look at their you may have to look at their side tables to tell you which is your actual total lengths and all of those kind of parameters. Questions on any of making components so far?
So for just copying and pasting pads, you Control C and then click after, right, to copy? Or how does it work?
Yeah. So if you want to, same process. So if you want to control paste, copy paste stuff, Control C. Let's get on this. So you'll click the component you want, Control C, and then you can see I have my green crosshair that's floating around. That's your reference point. So if I were to just click it over here, and then I go to Control Paste, you can see that it's wanting to be way over here again. So if you are going to copy paste something, you want to make sure that you're doing it off the center reference. So when you're placing your next, you're placing it about its center as well. You do just have to make sure when you're doing this, you go change the number, since it'll have whatever it was.
Do you want to show them paste special or paste array?
Have I even used paste array?
So like just delete 2 to 6. Copy 1. Yeah, just copy it. Then you can go to Edit, top left. Paste special, a little bit above. Yeah. Paste on current layer, and then paste array. So now here you can just put a shit ton in one move. So you can hit 6, and then text will auto increment by 1, and then X spacing to just change it to 2.54. Yeah. And then wherever you want to start it, and it'll do it all.
Just does it for you.
I think we actually did 2 of the first one, but maybe fix that. So there should be 2 ones there by accident. Oh no, it's 1. Okay, great. We're fine. Oh no, yeah, there's 2. Yeah, so if you have like 20 in a row and you know the spacing, you can just do that and it'll auto increment all of them for you, nice and easy. There's also a circular as well if you have a circle pattern.
Yes, so that is a fun thing that I have never dealt with or played with. I've always just done the manual incrementing.
Yeah, there are like thousands of tricks that I don't know either. Just like people randomly find. It's like, oh wow, this is cool. And Jay was asking about surface mount headers.
Yes.
So like, is this, how do I tell if this, like, are these pads on one layer, like the top layer or the bottom layer? Or like, how do I tell what this is?
So for this one, because we set these to multi-layer, this one is going through the board, and it is it has those surface pads on both. So we can see the top solder and the bottom solder. They both highlight. That is, we do have an accessible solder pad on the top as well as on the bottom layer. So these, when you set them to multi-layer, is going to be a through-hole component that has solder access to both. Now, if this was, say, an identical header to this one, except we're just going to say that the spacing is the same. The only difference is, instead of a through-hole pin, it is just going to come out and it's going to be a surface mount pin and just lay flush with the surface. What we would do in that case is we would go to place a pad again, and this time, instead of a multi-layer, we would make this a top layer component. And so we see that we lost the ability to place the hole or change the hole size. All we can do is change the shape and size of this one. Now, typically, your surface mounts they're going to be rectangle. And you would just go about changing your X and Y based off your pin length. So we'll say 2 and 3 for right now. Here, let me pull up. I think this was a surface mount one. It's basically the same process as close. No. It'll be the same process. So you are just going to be placing the pad. Again, looking at the data sheet for what they tell you the spacing is, and then you're just going to follow that. So we can do the same thing. Yeah, so I pulled up this simple USB connector and the data sheet for that. They show us the pins for it down here, so we can see that they are 2.4 wide. Where can we see? They're not giving us a length, but they have.
Best move is just to follow their recommended. Yeah.
Yeah, basically every connector will give you this. If you had to decipher, you could go through and follow their dimensions, and you should be able to pull out something similar. But yes, best is to just go follow their recommended. So if we were just focusing on the 5 main pin pads right away, we would see that they recommend 0.4 width and a height of 1.35. And then those are going to be, I don't like how they dimension this, 1.3 is that pad to pad, so I really don't like how they dimension that. 0.65, I guess, is going to be the center to center of each pad. So if we so we just said it has an X of 0.4 and a Y of 1.35. So we can paste this one, and we'll do the special paste. I didn't want to paste array. We only have 5 of these. We're incrementing by 1, and the distance between 0.65. So we can see we were able to get the 0.4, the 1.35 for the pin height, and then it was 1.3 for pin to pin, so the pin to center is just half that. I don't like how this one's laid out, but regardless, so 0.65 for your pin to pin distance spaced across. So now we can see that we have just the 5 exposed pads as they recommend in the datasheet.
Is there a way for us to verify or validate that it actually did it properly for us, like the distance between them?
Yeah, so if we go control normally you could go control M, but because I have Skype open, that just mutes me instead of doing the measure. You can do reports, measure distance, or control M. Click on the center of this one, the center of this one. We can see it did 0.65. And if we were to go follow their dimensioning going from pin 2 to 4, we can see it's 1.3 mm. Just like they said it was from pins 2 to 4, that distance is 1.3. And we could verify all the other ones by doing the control M and clicking pad to pad, see what the distance is. But we can see that this is correct. The pin to pin is 1.3 like the datasheet says. And then if we go Shift C, it gets rid of the dimensions so they're out of your way. So that is a good verification, especially it'll be useful because we do have to put these pads as well. And since they're not as standard, they're not just 5 equally spaced, it's now referencing distance from center of this one to the top of this one. Your distances are going to be a little bit more difficult to actually make sure you're getting proper. So using Control M to verify your distance is super useful. I should have just made a new component. Questions on any of the SMD headers?
What did that plated checkbox mean on the right?
Which one was that on? For the...
I think just above size and shape. A little higher, there's that checkbox. Yeah. What does that do?
That is, yes. So having the inside of your circle inside of your drill hole being plated or not. So we can see our left one was plated and our right is a non-plated. So we can see the electrical connection, the solder mask, not solder mask, is continual. They coat the top through the inner of the ring and the bottom, whereas for non-plated, it's just top and bottom. You don't have the connection between through the hole. In most circumstances, especially with headers, it is better we just keep these all plated.
Yeah, basically it allows you to have a connection from bottom to top, right? So if I route something on the bottom layer to that pin, it would connect to the top layer as well through the plating. So I could also route something from the top if I wanted, if that's more easy as well.
Yeah. I mean, I guess that's one way to, I mean, once you start getting into high-speed design, by not plating your holes, you can get rid of the stubs in your design, which are known to be bad for high speed and EMI. But that is way beyond our workings. So for the most part, we keep these plated because we want connection through and through.
Yeah, I actually made the mistake of not plating the other day, and Altium gives you a DRC error.
I would actually it throws an error.
Yeah.
I almost always just glance over that, so I've never.
Yeah, it's supposed to be default on. I don't know why mine were off, but yeah, it's important to have that checked.
What was the other thing I was about to do? Oh yes, so why I went back to the through hole. If we have a connector like this, we can see that it has pin, and then it has this additional plastic nub to it. So that is, it basically acts as a little locking pin to go into the board. It helps secure it to the board and kind of locks it in a little bit better compared to just having just the pins. So some connectors will have these, and we can see that again, this data sheet that's meant for this 2x1 connector is giving you the pad layout and the reference and the plating and diameters for several different connectors. So you do have to make sure that you come into this knowing that I have this 2x1, so I have to make sure I follow this this footprint style. But basically what we have to consider now is the distance between, well, for one, this header is a little bit larger, so we have our hole size is now 1.8 and our distance between is 5.5. And do also always make sure that you go and check the dimensional units of your data sheets. Sometimes they'll tell you that it's millimeters on top and inches on bottom or whatever it be. But do make sure of of your units before, because if these were all in inches, but I just instantly assume millimeters, you're going to be way out. And in most cases, it'll be obvious, because if you were to do 1.8 inches instead of millimeters, you're going to have a massive hole. But if it's mils to millimeters, it might be a little closer. But it can mess you up by just enough that it's unusable. So do pay attention to your units when you're making these. But yeah, so we can go 1.8, and the distance is 5.5. So if we jump back, 8, and we're going to want our hole to be larger again, so our pad to be larger, so say 2.3, 2.3. Same thing. Because I didn't have the grid on proper, this distance isn't going to be right, so I can just go and call this at minus 5.5, because I know that's what the data sheet says. And then the new parameter that we have to deal with being now the hole for the nub. It is an additional 7.3, and it's a hole of 3 millimeters. So we go and again just place another. This one, it doesn't matter. It can be a pad or a via. Just since it has no real, it won't have a connection. It won't be, we're not electrically connecting this to anything. So we said its hole size was 3. And because this is for the plastic nub, it doesn't have any electrical connection. We don't want it to be electrically connected. What we can do is also set the pad to 3 and 3 as well. Basically giving it nothing additional to actually solder to. And this was, it was an additional 7.3, so that's so now it's going to be that proper distance, and it's just in line with it. Yes, and that's.
You can also unplate that one. I think that would get rid of that metal.
Yeah.
Mhm.
So this is basically nothing but a drill hole in the PCB. If you don't unplate it, or if you just leave it plated, it doesn't really change much. It doesn't matter. It's an additional step for them when they're making the PCB, but it's not like it. If you miss this, it's going to cost us more. But yeah, for the sake of this doing nothing except being a drill hole, we can have these unplated. What are we at? Basically 50 minutes. Any questions on anything we've gone through so far? Okay. Then the Then I get, yeah, so the final thing I'll just show you, we'll just stop at this. We won't go into the setting up a project or anything. When you have something like a header that you're, or any component that you're making yourself, obviously if we just do this, this is going to be what it looks like when you put it on a PCB, just the 3 holes, compared to when we were using the wizard. It gave it its nice, it gave it a nice look to look like a proper connector or a proper chip or whatever it was. We can do a similar thing whenever we're making items. So if we pull this back up, especially for headers, it's quite common that you can go down and find the step file for them. So we can download these. And that's just going to be in downloads. Place it. So what we can do is place 3D body, and then if we go tab, we can go change it to generic. Geez, it's been a bit since I've done this. So if we go generic, leave it on the embedded model, choose the path, you get a little window. The one that I just did, I left in downloads. So you'll see it gives you a nice pink block, and we can't really tell what it is at this point, so we'll just click it down for now. And if we go into the 3D model, we can see that it is definitely not sitting upright like we want it to. So this will be Z rotation. What axis are we looking on?
Like X180 and Z, sorry, X90 and Z180.
90. Yes. So we can see that would now fall in the proper orientation. That is a bit of a manual process when you throw in a device. You do just have to play with the XYZ. It's typically by perfect 90-degree rotations to get it to the proper orientation that you're designing. And then we can see that it's sitting what would be in the middle of a PCB, so we have to change the offset to something. It doesn't really matter, so I made it 4.5, but we can see that would actually leave it floating a little bit. You don't have to make it perfect. This is purely just going to be for the looks when you are putting it on a PCB. So it doesn't have to be perfect, but if we are to line this up, and this can be your final verification that you put all the pads and the holes in the correct position, that this 3D model from the manufacturer is fitting within all of our holes for the most part. Grid size is going to matter. You're going to want it finer. But yeah, this can be your kind of final check to be like, yeah, I have full clearance. It looks about proper. And then you get the nice model for when you put it on on your PCB. Again, this step isn't necessary. Like electrically, schematic wise, full system wise, everything will work exactly as you want it to if you don't import this step model. But it does just look better when you put the full PCB together. And again, final verification that your holes are lined up. And to anybody wondering how I'm navigating all of this, if I press 2, I'm on this screen, the 2D layout screen. If I press 3, I go into the 3D model. If I hit 0, it just brings it flush on top. VB, or what is it, view, or here you can see the 90-degree rotation, the orthogonal, so you can do all of these rotations, or just V, where B just does a full flip around, and then shift and right click drag is how you can manually look around at it, just for wondering how I'm moving it around. Questions on anything? I think that's going to do it for today's lesson. So any final questions on through-hole, SMD, bringing in components, lining up, pin numbering, anything?
Is there really no better way to line up the 3D model?
No, I don't think there is. Maybe. So what does that do? Yeah, because like it's not. Its body isn't going to be the same. Have the same coordinates. So like I put it at x0 and it threw it all the way over here when that is 0. So obviously you can't just go and know what your x, y's are supposed to be and plug it in, because it has a different. So for what I know, it is just a manual. Shift it over a little bit, look at it, line it up that way.
I see. It's an optional step anyway, but if you want to make it look nice in like a picture.
Yeah, like if we are to bring in a real board, like it does nothing but it, just for the sake of it. How did I open up the right one? Like, yeah, when I did this board first, I never generated the step model for the main chip, so it's just a nice block. I messed up on some of them even, but yeah, by adding in the step file for your headers and any extra components, it just makes it look better for pictures. Anything else? Everybody understand the making of components? And I mean, again, these are all done in the Phantom library. So let's hide those. So like all of these headers all of your main chips, capacitors. These components are already made, so for a lot of this, you don't have to go make, if you're continuing to use the Phantom library, you don't have to go in and remake all of these to be able to link it. A lot of things will share the same footprint, especially component level. And I did a fair amount of different headers that we don't really have to be making more, for the most part at least. But for whenever there is a completely new component and you need to make it, this is how we do it. Okay, if there's no final questions, that will be it for the lesson.